It's a big, beautiful blue planet, and the adventurous natives have been exploring it all over, from the very beginning. Lately, they've been exploring off the planet, determined to discover what's out there. But as luck would have it, their pursuit of their future has also been building their present. They're enjoying benefits today that are coming out of the work about tomorrow, work that's being done right now, aboard the International Space Station. Since Expedition 1 arrived on orbit in the year 2000, there have been more than 1,500 investigations active on the International Space Station in fields like medicine,
protein crystal growth, combustion, metallurgy, basic science, space science, Earth observation for disaster recovery and relief.
And many of those experiments and research projects have produced beyond the original intent. For example, a lot of the work in medicine was designed to keep astronauts safe in space, such as research on how to keep crew members from losing bone mass and weightlessness. And the researchers found that nutrition was playing a part.
Individuals had more iron storage in their body, had more oxidative damage, and had more bone loss in certain regions.
So, more attention was paid to providing foods with the right kinds of minerals and nutrients. Then, there was better exercise support, like an upgraded exercise device that proved its effectiveness in crew members who flew with it after having flown without it.
After the first flight, I lost 99% of bone loss. After the second flight, during all those prescriptions and exercises that I've been told to do, from bone loss perspective, I lost nothing.
The right combination of exercise and diet and vitamin D supplements meant no bone loss.
So there's been a huge development of our understanding of bone processes, why astronauts are losing bone, and how the bone remodels and recycles itself. Understanding that process helps us protect astronauts, but it also has the benefit of giving new insights into understanding those same processes on Earth, where so many people are worried about bone loss.
Another example of station research providing a benefit on the ground: water reclamation. Early on, the station crew members relied on space shuttles and other cargo ships to deliver fresh water. But the long-range plan was for a more self-sufficient station with a system that turns wastewater into pure drinking water.
On board the space station, we've had a water recovery system in use since 2008. This system recovers 90% of the water that we fly to the space station. This technology will be vital for our long-duration missions, and that's because on a deep space mission, the water resupply won't be practical.
And where else do you think this technology is proving useful?
The water treatment system that we developed for the space station has been deployed over the last 10 years now all over the world.
When you get involved with a plant of this kind, if it is well used, it can change the lives of an entire community. It gives you children that learn more. It gives you parents who spend less money on medicine. It changes the future.
And then there's space station activity that was designed to benefit people on Earth. For example, students on Earth, from grade schoolers through postdocs. Since the beginning, station crew members have used an amateur radio to talk directly with students on the ground, answering questions and inspiring some of them to careers in science, technology, engineering, and math fields. More than 500,000 students have learned about geography and teamwork and communications and problem solving by participating in an experiment that lets them control a camera on the station and aim it at targets on the Earth of their own choosing. The Spheres experiments originated to test algorithms related to formation flying, but it's evolved to include students in the design and execution of those robotic flights. The International Space Station has a lot of goals. Not only is it getting people of this planet to work together and enabling deep space missions of the future and seeding the growth of commercial space ventures, It has an ambitious agenda of laboratory science and technology research that's using the unique environment of low Earth orbit to learn what can't be learned here on the ground, to help people on the planet right now.